All right, welcome back, everybody. So we're going to go over quickly the last two parts of this tutorial. The first part of it being artists. So in the last two sections, I've showed you how you do plotting. I've showed you how to modify your plots and how to customize a lot of things. But really, I haven't said what is it that you're doing. What is it that you're playing with? All those things that you see on your plot are called artists. They're artist objects. It's just generically artists. Anything that is visible is an artist. Text is an artist. A line is an artist. A polygon is an artist. They're all artists. Heck, even the axes object, technically speaking, is an artist. And supposedly the figure is also an artist. So I got to double check, see if we changed that sense. But or the figure object does contain artists. But anyway. So just a quick little demonstration of what kinds of artists we have. We run this little thing and shows up a few various predefined type artists that we have. Wedge, arrow, line 2D, rectangle, ellipse, all this stuff. And so all these artists have these properties that we've been playing with: the line width, the edge color, the face color, the line style. These artists knows what these properties are, whatever is relevant to their particular thing. Obviously, a line 2D object doesn't have a face color, but it has a color. So these are some of the many primitives. These are the many artist primitives that we have. These have a correlation with the various backends that have their own type of primitives. So this is sort of the GUI-less agnostic primitives that we then translate to the particular backend that you're using. So in a particular backend, it may recognize what an arrow is, but that backend may have to treat it as a combination of a line and a triangle. So we take care of all that. We abstract all that stuff away from you guys, and we say it's an arrow. So, and then it works seamlessly across all the different backends. So whether you're saving it to a PDF or you're viewing it in a GTK app, it works. Then there are container artists. These are things like the figures and the axes object. They hold other artist objects and they hold on to them. They don't really draw themselves, but they draw other artists for them. So, and then with those container objects, we have a bunch of convenience functions that help build the primitives. So when you call plot.plot or plot.scatter or plot.hist, we take all that input information and inside, under the hood, we create all these different polygons and lines and stuff like that, and we add them to the container of the current axes. And so that's how this all works, is that you see pretty plots. You don't have to worry about these artists. You don't need to know necessarily what they are most of the time, but they exist, and so we do all the heavy lifting for you. But this also means that you guys can create your own plotting functions if you wanted to. If you have an idea for some crazy plot that works well for your own data set, and none of our plotting functions work well for that, you could actually take on the role of a developer, in a sense, and create a function that takes in a bunch of input data and builds up these various primitives and adds them to an axes object. And voila, you got yourself a brand new plotting function. And it's the same exact thing that the PyPlot module does. So just a quick little, and so plot.plot, for example, is going to return back a list of line objects. So in this case here, I have made two lines, one that's going to be blue and one that's going to be red. And so that means that that what gets returned is a list of two lines. I'm going to set some property on the first one, and I'm going to set some other properties on the second one. Note the second one, I've set the alpha to 0.7. And we talked about Z order earlier. The second one gets put on top of the first one. So we can see the blue one a little bit through that transparency there. And so this is how you can actually specify in a different way some of the properties of your artists, is that you can capture them and modify them directly yourself before you do the show. So one way to find out what properties are available, this is an example. So a figure object has a part of what's called a patch, which is basically just the backing of the canvas. If you didn't have a patch, your files would actually be transparent rather than by default it's white. So whenever you make a PNG file or something in Matplotlib, and you have a white back end, everything's white on there, that's because the patch object by default is white. You can change that to be something else. But let's just take a look at what some of the properties are of that particular patch. Some of these probably won't make any sense. AA means anti-alias. Ag filter, don't worry about it. Alpha, there's something you know. Animated, don't worry about that unless you're doing animations. Again, anti-alias or AA. We already did AA. Axes says what axes it belongs to. Since this belongs to a figure, it doesn't have an axes object. The B-box. B-box means bounding box that it belongs to. Here it goes from 0, 0 to 1, 1. What children does it have? Well, just simply its own, so it doesn't have any children in terms of like what, the patch is not a container object. It doesn't hold anything. Meanwhile, a figure would have children. So, clip box is a B box that says what the clipping will be. So if you wanted to, so we do that with let's say the histogram plot or a regular plot. As you zoom in, you don't want the lines and stuff that is outside of your limits to show up. So you clip them to the bounding box that you want it to be for. Again, a lot of these things you're never going to have to worry about. But here, EC or edge color. We have base color or FC. We have hatch, line style, line width, LS, LW. We have, let's see, we talked a little bit about the transform. We have a bunch of other things. So these are all, this is what happens underneath the hood. And so it's all there, it's all available if one wanted to. The Z order is right there if you wanted to mess around with that. It's all available. Collections. Collections is another type of artist that is obviously the collection of artist objects all of the same type. So if you have a whole bunch of circles, you would have a circle collection. If you have a whole bunch of line 2Ds, you'd have a line 2D collection. And so with that, with one of these collections, you can logically have them all together, and you can act upon them, do the same thing to them all together. So for example, the histogram that you saw, that would be a patch collection because there's 4 of them, and by default, you want them all treated the same way, and all, many of the properties are going to be shared it's all going to have the same color. They're all going to have the same line width. But you could mess around with the individual ones as well. Or let's say when you do a scatter plot, and so you have all the scatter markers together, what if you wanted to change the color? Did you want to really do a for loop over every single one of those marker artists? No, you get back a patch collection, and you say, I want the color to be blue. And it sets it for all of them. So that's what a collection is for. So here I make a collection. Most of the time, again, you're not going to need to deal with this, but it's good to know that it's there, that that's what it is. So I make a line collection. There's going to be 3 lines. The first one is going to have going to have a start and end point. The second one is going to have 3 points. And the third one is also going to have 3 points. I want them all to be red. I'm going to set the line width to be 5. Let's take a look. So we have 3 lines here, and they're all red. Now, what if I want to set an individual value? Well, I can. So I want set color, and I give a list of individual values. And in this case, I give a red, a blue, and then an RGB tuple. This is the one place you can do an RGB tuple. And then I want the line width. I give, again, a list of line widths. So now I can individually modify each one. But then all the other properties are the same. And that's sort of, the collection kind of helps simplify management of your many, many artists that you may have. And that's what they are. And that's all artists are. Artists is just whatever gets drawn to there. And so all your plotting functions return back to you either a list of artists or a collection of artists or artists themselves. And if you really wanted to get down to the nitty-gritty of things, you can modify those properties directly if you wanted to after the fact. All right, so that's the quick and dirty thing on artists. Yes. Finally, MPL toolkits. We're almost to the end, all right? So there are some extra toolkits that exist that, for one reason or another, are not actually in the core part of Matplotlib. It doesn't necessarily mean there's anything wrong with them. Matter of fact, for one of them, there's a lot of things that are right about it. It just doesn't make sense to ship it with Matplotlib. There are more than the ones that I'm going to talk about, but there's 3 in particular I want to highlight. The first one is called basemap. We do not ship basemap with Matplotlib because it is so big. It contains in it a whole bunch of very high resolution geographical data. The download for basemap is about 120 some odd megabytes, if I remember correctly. Maybe even more than that now. And so shipping Matplotlib, which is only 10 megabytes or something like that, with basemap, most people don't need basemap, but a lot of people, but there's still a large audience for it, and so we make basemap be separate, but yet still a part of the ecosystem. Then there's Matplot3D. This is actually a project that I maintain. I promise you, once I finish my dissertation, I will get back to maintaining Matplot3D. Matter of fact, I'm going to try to beat out a few of those bug reports that I've been letting languish for a little while now this week. So, Matplot3D is a very, very simple 3D plotting library. It is meant only for very simple 3D plots. If you really need some very advanced stuff, there are better tools out for it. But the idea with Matplot3D is that, hey, I just made a whole bunch of these 2D plots and I have this one 3D plot that I want to do. Well, why learn a completely different library that's just for a 3D thing when you have this just one simple request to do? We can handle a simple request of a simple 3D plot. And it will be in the same style as all your 2D plots. So that's one thing that's really nice that a lot of people like about it. A lot of 3D plotting libraries, they're more geared towards very advanced types of plots. And so you go, but I just want, a stupid wireframe, or I just want this, and you just don't know why it's so complicated to do in these other libraries. We do it in the same style in mplot3D as you do in Matplotlib, and so a lot of people like that. Don't try to do anything complicated, and it will work fairly well for you. Then finally, AxisGrid 1, which, as I describe as an enhanced subplot axes, very enhanced. So just to quickly kind of show off mplot3D, I'm not going to show off basemap because I didn't make it a requirement for you guys to install, so I don't know how many people here actually already have it installed. I would highly suggest going to, if you're interested in doing geospatial plotting, I would highly suggest going to the documentation and taking a look at just how dead simple it is to plot something in various projections in doing these sort of things. And then if you have any questions about the basemap, you go to the Matplotlib mailing list. And Jeffrey Whitaker, who's the main maintainer for this tool, he responds to questions on the mailing list there. So he doesn't have a separate mailing list for basemap. You go to the Matplotlib mailing list for that. Okay? So again, if you're curious at all about doing geographical plotting and things like that, basemap is your friend. Another possible tool that I haven't tried out yet but is up and coming, it's called CartoPy. It's useful. There might even be a few talks about it this week, so I would keep an eye out for it. mplot3D, basically you treat 3D plotting as another projection. So we say 3D projection, and in this case I just did a simple example where I'm just grabbing up some test data that I have and I'm going to do a wireframe, and there you go. And it looks a lot, everything will operate a lot like how you would normally expect it to do in 2D, but with a third dimension available. So you can set the Z limbs. So you can set X limb, you can also set Z limb the same exact way. So a lot of the things that you come to learn to expect to have happen with 2D plotting, you can do with 3D plotting as well. I've worked very, very hard between version 1 and version 2, version 1.1 and version 1.2 to fix a lot of bugs in there. And so there may be a lot of people who tried mplot3D back in the version 1.0 days and didn't like it. I fixed a lot of things since then, so you might want to give it another shot. AxisGrid 1, this is what I want to spend a little bit of time with. It's a really, really neat toolkit. The only reason why it's actually not in Matplotlib proper is because it doesn't work perfectly with Matplotlib core. It changes some behaviors, and so therefore we couldn't include it as part of the core library, but it does so many other things so well, we just couldn't ignore it. So we made it a toolkit, and it's good for a lot of uses. Basically, the things that it doesn't work properly for are ticks and tick locations and things like that. Like if you try to do some of the more advanced stuff that you would do normally in Matplotlib, this stuff, it doesn't quite do it the same exact way. Oh well. So just kind of show off what I really, really like about it is AxisGrid. you think, oh, this is a really complicated constructor, but it actually makes a lot of sense. So I can say that all the axes that I'm going to make, I'm going to do a 2x2 grid of axes, and I want a certain amount of padding in it, and I want all the axes to share their x and y's, let's say. Oh, and the label mode, something I didn't go over earlier. There's a function called label outer, which really is useful if an axis know that it's an outer axis. So if you're doing, let's say, a 3x3, you don't want the tick label to show up or the x and y label to show up on all of them. You only want it on the outer ones. Well, this L here, the label mode equal L, is the same thing as label outer. And so what it means, you'll see it in a second, is only the first column and the first row will have their labels. And then C bar mode equals single. It will pre-allocate a single color bar, a spot for a color bar ahead of time for you. That way you don't have the problem that I showed earlier where a color bar stole space from the last axes. Here with C bar mode, single or all, it will pre-allocate it all for you ahead of time. So this example kind of shows how to do it. So you see the label outer. So only the y-axis got the labels here. Only the x-axis got the labels here. All of this is blank. Because remember, I said it would share all the axes, so why repeat that information again and again? So it kind of helped clean things up. And then
if I commented that out, that label mode is equal to L, if I comment it out, you get the same thing.
I think the label mode is L by default in AxisGrid. Okay. And Matplotlib proper is not default. And then there's other label modes. And so I like having the label mode there to just kind of demonstrate that does exist. So there's other label modes you can do. I don't recall what they are, but L is typically the one I do use. And then you have your color bar here. And so notice that all these axes are all the same size. None of them look a little more shrunk than the others. AxisGrid pre-allocated that color bar axes for me ahead of time. And then, yeah, so I still don't know exactly what to call this next feature. We have a name for it, but I don't really know how to describe it. But we call it a Parasite axis. And it's just better just show you. So here I'm plotting, let's say, density, temperature, and velocity. These are three different things that don't really belong on the same plot. They don't have the same data coordinates. They're not the same variable, but yet you want it in the same axes. So you can say density here on the y-axis on the left, and then temperature there on the right, and then boom, have a third one even a little bit more to the right, which I just absolutely love. When the few times that you do need that, AxisGrid makes this dead simple, easy to do. It's possible to do this in Matplotlib proper, but you don't want to. You want to use AxisGrid instead to do this. So if you ever wanted to do this sort of stuff, it's available to do. And then this is another really neat thing that can be done. They're called floating axes. Again, you could, if you really, really tried hard, do this sort of stuff in Matplotlib. Somebody else did it for you and made it in AxisGrid instead. And so if you ever needed to do something like this, this is where you go. So then there's a lot of other things that AxisGrid can do. So if you ever find yourself in the need of, I need some weird custom thing to do with my axes, chances are AxisGrid does it already. And so if you go to the documentation for AxisGrid 1, you can go through and you can see the different sort of things that you can do. And you can pick it out. And these things are available also in the gallery as well. So if you want to do inset stuff, I like this one. You know, you can have that inset there and it show up like that. It's really easy. If you want to do RGBA channel type views, some of the original spine work was done originally in AxisGrid, and we brought some of that into the core Matplotlib. There's that Parasite, and then some polar work. So these are the sort of things you could do. There's actually some other stuff I'm not even showing here. It's just neat, nifty toolkit that's available. So that's that. And I think I've largely covered a lot of the stuff I think is in Matplotlib. There's still more. And I really encourage you guys to explore the documentation. And if you come across something you don't think is explained well, let us know. Send us an email on the mailing list. And we'd be we always welcome your feedback. And then we're going to have sprints and Birds of the Feather meeting this week. So feel free to drop in on those and can give us feedback. If something doesn't work quite the way you thought it would work, ask a question on the mailing list, and we'll be more than happy to help you guys out. And I really appreciate you guys coming today for this tutorial.
Thank you.
All right, take care. If you have any questions, I'll be here for a little bit longer. So.